Hello, calculus students. We're going to take a look at a problem from your chain rule homework with a square root. There's another video I've done with a square root in it also. But this one's actually a little simpler than that one. So this is problem number 14. I've also done problem number 18. And there's a video on that. So we're asked to find dy dx, which is the derivative of y with respect to x. I want to know how y changes when x changes. And y is a square root of 2x divided by 9x minus 7. Now, why are we using the chain rule now and we didn't before? Well, if I look at what's inside here, 2x over 9x minus 7, the derivative of that is not a 1. Up until now, I've only done derivatives of square roots where whatever was inside. Now, it might have been an x plus 2. The derivative of the x plus 2 was a 1. So if I were to take the derivative of this, I did 1 over 2 square roots of x plus 2, and I said, okay, I'm done. But what you didn't realize you were doing is you were actually multiplying that by the derivative of x plus 2 with respect to x. Well, the derivative of x plus 2 with respect to x is just a 1. When we multiply a 1, it doesn't change the value of anything, so we don't bother writing it. So we've just kind of ignored the chain rule until now. Now, I have had some students say they wished when we were doing these, I mentioned that we can skip this step because these derivatives inside are always a 1. This is also what we call a composite function. You have the square root of some other function, and that function is a function of x too. Well, the key to these is dealing with it a piece at a time. Like, what is the pattern for taking the derivative of a square root? And the reason I'm going to start with the square root is because that is the outer function. So how do I know it's the outer function? Well, if I gave you a value for x, you would calculate the 2x, you would calculate the 9x minus 7, then you would do that division, and then you would take the square root of that number. The last thing you would do is take the square root if you were evaluating this function using the order of operations. The last operation you do is the outer function, the outer operation. So how do I take the derivative of a square root? Well, the pattern for that is it's 1 over 2 times the square root. Because if I write this to the 1/2 power, it becomes to the negative 1/2. But it always boils down to this. 1 over 2 times the square root. Well, what do I put in the square? Exactly what you started with. Don't change a thing. You've taken the derivative of the square root. You've not done anything about that inner function yet. And when you finish with that, you still have to multiply by the derivative of the inner function. Let me erase some of this because it's getting messy. So I still have to multiply by the derivative of what's inside, and that derivative is not going to be a 1 this time. That's why the chain rule has become important. Now I have a 2x over 9x minus 7, and I actually am going to need the quotient rule to do that. So the next step is just to find, I'm going to leave all this written down, but I want to just do this now. This is kind of like a new problem I have to do. So that is a quotient, f equals 2x. The denominator, which I call g, is 9x minus 7. Here's all the parts I need for my quotient rule. The derivative of f is 2. I started to write something else. We don't want something else. The derivative of g, the bottom, is just a 9. So I need the quotient rule. The quotient rule says I write the bottom and square it. That's the bottom function. I square it, and then I write the bottom function up here again and multiply it by the derivative of the top. So this gets multiplied by that on top first. And then I subtract the top function times the bottom derivative. Now, right here, this 9x minus 7 has to go in parentheses. A lot of you aren't writing the parentheses. If you don't put two terms in parentheses, you're not going to multiply them both by the 2. And the intention is that the whole bottom function gets multiplied by the derivative of the top. So if you don't have those parentheses, it's wrong. So I can simplify this. I don't need to necessarily in my math lab. I could just take this whole thing here, this whole fraction, and write it after my square root if it's not requiring simplification. But this one simplifies kind of nicely, so let's look at that. And in these, really, we hardly ever want to write out. You don't want to multiply out that bottom. You want to just leave it like it is. And that's going to leave me with this red part is negative 14 over 9x minus 7 squared. Well, where does that red part go? Well, that red part goes in the place of this red box here. That's what that is. So when I do the whole thing, I get y prime, first I dealt with the derivative of the square root, is 1 over 2 square roots of, extend that a little bit, 2x over 9x minus 7, times, this red part was negative 14 over 9x minus 7 squared. Now that can be simplified. You don't ever need to simplify that for me. And from my math lab, sorry, I'm having a technical difficulty here. For my math lab, if you just made one big fraction out of this without simplifying, I think it would be okay. But let's look at how we would simplify this. Since we're in calculus and we should know how to simplify things like this, let's review that. So square root is like putting it inside a 1/2 exponent. So I'm going to do that. So I get a 2. So I get negative 14 over 2 times a 2x to the 1/2 over 9x minus 7 to the 1/2. That's how the rules of square roots and radicals work. And exponents and radicals work, rather. And then, so when I multiply a fraction, I get 1 times negative 14. That's where the negative 14 on top came from. And then it's bottom times bottom. So this bottom is right there. So I'm actually going to be able to reduce this 2 with this negative 14, and that'll leave me with a negative 7 on top. I can't do anything with the 2x to the 1/2 power, but when I multiply this 9x minus 7 squared over 9x minus 7 to the 1/2, I can subtract 2 minus 1/2, and it gives me 9x minus 7 to the 3/2, because 2 minus 1/2 is 3/2. It's 4/2 minus 1/2. So this is how this whole thing would simplify if you were required to simplify. And you're not, generally. So that is the chain rule with a square root. Okay? Thank you for joining me, and email me any questions you have.